Hello and welcome to my video on my DS2TILE graphics converter. So this tool is what I use for converting my graphics from PNG files to various tile data formats. So I'll give you an example here. So this is some graphics I was doing the other day, and this is set for 16 color mode. So we've got the color palette for the characters here, and you can see we've got the animation frames all set up for us here, where I've been tweaking around with some Pokemon characters there. So this is all ready for the conversion process. And these tiles here, so the GameBoy Advance and the DS, they pretty much use exactly the same file formats. So we have a 16 color mode, we have 256 color tiles, so we can have 16 color tiles, 256 color tiles, or we can have a 256 color bitmap or a 16-bit bitmap. The only difference is the bitmaps on the GameBoy Advance are smaller than those on the DS. Also, the DS, when it comes to color palettes, they have an extra bit associated with the alpha flag, which is how transparent something is. So for example, if I do this, you'll see that color there is actually transparent. So if I replace that, this would now on the desktop on a desktop PC, if I was to draw this character here on the screen, it would not corrupt the background. So I can show you that here. So if I copy this one out and then paste him in here, and then we zoom in, we can see that the color with the alpha value set to 0 doesn't obscure the background at all. So another thing I'll touch on quickly before I start going through various demos here of how to use the program is, so the program I use mainly for creating my tiles and graphics is LibreSprite, which is this here. This is a free open source program. I find it quite useful. Very minimal as well, which is precisely what you need. And then another program is Inkscape, which is this program here. So this allows you to create nice vector graphics, and you can always convert vector graphics to pixel graphics later on, which I do many times. So for example, this nice font here, for example, if you wanted something like this on the Game Boy Advance, you could go into File, Export PNG, and then you'll see here it's 776 by 176, which obviously is way too large for us. And then other things you can do here as well is you'll see that it's got anti-aliasing. So anti-aliasing is what happens around the edges of images, where to smooth things out there's like an extra border of coloured pixels between one colour and the other, so that you don't see the jagged pixels. So you can export that as anti-alias none. So if we do that, let me see, where shall I put this? In fact, no, I don't want it in there. Put it in here for now, and we'll leave that name there. Now if I navigate to there, here we are here, and I can then open that in LibreSprite. Which we have here, and now you can this is now a pixel image here. So we could then scale this. There we go. That looks quite terrible, but bear with me here. So we'll copy this. Now we also need to have the GIMP graphics editor here, and I'll show you what we use this for now. So paste that in as a new image. So at the moment this has way too many colors, and then you can use this conversion program here. Go into mode, go into index, and then we can put this as 16 colors, and then we've got various differing options here. So what differing is, for those who don't know, is it takes what colors are in the range of these 16 colors and then kind of blends them together to create a missing color from the original image. I'll show you here. This is probably not a good one to show, but anyway, it's converted this to 16 colors here. And then one effect you'll see if you look is it looks very grainy. So we probably would not want that. So if we undo that, and then let's have a look at another index one here. So we'll put it to none, see how that looks. None is going to be probably what's best most of the time. And then copy this out of here back into LibreSprite. Didn't mean to do that. Now we could now use this on the Game Boy Advance or the DS as a title, and then we could decide whether we wanted to it to be tiles or a bitmap. This is not a great example here, so we'll get to something more interesting. So I'll jump back into here, and then we'll open this picture here up. I've probably already, so this here was used for a ring dash game, but I've created for the Game Boy Advance. So currently this image is fine. I'm not sure how many colors exactly are in here, but as we'll be converting this into tiles, it's always best to have a background color. So a color I always use is bright magenta here. Now we want to make sure that this is 16 colors, as it's going to be a 16 color tile. So put this in here and then go into index, and when you convert that, this is now 16 colors. And put that back into here. Now one thing to note as well is, as we're converting this into tiles, the size of this needs to be a multiple of 8. So if you go into grid settings on this, put this to 8 by 8. This works fine. So some images you'll get a lot of wastage where there are these blank tiles here, but we'll save this one for now. Just save that. Now this here will be the Linux version of my program here. So the only dependencies you'll need for Linux or Mac, if you're going to use it on that, is SDL2. And specifically you need the SDL2 image and SDL2. So we can run this, and then this is the tool here. It's very minimal, and the way it works is you just open the folder where that graphics was. So this is the one we want to use. We're in 16 color mode here. Now this icon here expects the color palette to be in the top left, but I also have another mode here, which is the one we'll use for this demo here. And what this one does is it will create the palette from the image. So it will scan over the image's surface first and then create a virtual palette from all of the color pixels that it finds. And then if you've got too many colors there, it will tell you you've got too many when you go to save it. So this will be an 8x8 image, or rather, sorry, an 8x8 tile image. So we don't really need to change the size here. And then all you do is drag and drop it in. Let it go. There you go. It's found 16 colors, which is fine. Now pressing the left mouse button will zoom in. Holding down the middle mouse button will move it around. So now all we need to do is to save that. So click on save, and then so when you do it, there won't be a tiles folder here. So for me, I'll be just doing this, and then we save this as a C file, and then it tells you how many tiles it's saved. Now if we navigate to the tiles folder here, and then you open that in a text editor, here's your color palette ready for you to copy into an array. And here are all of your tiles ready to be copied into an array. So that's how 16 color mode works. So if we wanted to convert this image here of various floor graphics, I'll quickly open this in LibreSprite here. So these are 16 by 16 tiles here. In this mode I usually have, so this is a common color palette for all of them here. When you convert an image, you can only have one color palette in that image. So one reason why you would specify the color palette here is because you get to control the background color. So in all these 16 color palettes, the background color, color 0, is never drawn unless it's the first palette, which then color 0 becomes the background color of the whole display on the Game Boy Advance, and on the DS it's only ever the lowest background layer. So if we tried to convert this image group here without the color palette, then it would take this color here as being the background color, and then every instance of this color would not be drawn when we tried to draw these tiles. And another advantage of using the palette as well is it means you can easily refer back to the colors you're using, and sharing the palette between multiple images is nice and easy as well. If we wanted to create a new tile which used this color here, we could literally just do a new 16 by 17, come back in here, copy out our color palette into our new image, and there we go. We can use the pipette icon here to select our new colors and then draw whatever we want here, and that would be our new tiles. So to convert this one here into tiles, what we would do is we'd put in our size in pixels. We then would have the image palette from the top left, and then we drag or drop our image in. Tells you how many colours it's found. And then we would just save that out again. Now, one thing we might want to do here is we might want to separate these individual tiles, or at least know which bytes and whatever are for a specific tile. So if we click this one here, then this will export the number of each tile. So if we save this one, so on Windows this will obviously look different here. Then if we go to where those tiles are, open them again in a text editor, and then you'll see these tiles arranged here, separated by the image numbers. So when you copy these into your image array, these will already be commented out. So the same process applies when working with 256 color images if we wanted to convert them to tiles. So these aliens here are 32 by 32 pixel frames, and they use a number of colors. So one thing to do is you set up the settings before you drag and drop the image in. So we will now configure this for 256 color images. As you can see there, it's found 32 colors. So another thing to note as well is when you drag and drop an image in here, what happens first is I convert that image into 16-bit pixel format, as the images need to be in that sort of format to convert the pixels to the correct format for the Game Boy Advance and the DS. Basically every the pixel ranges are in steps of 8. So the 255, converting that to the Game Boy and the DS would actually be 31, which is the maximum color range. So you basically divide whatever color here by 8 to convert from the desktop color range, and then to convert back from the Game Boy Advance to the PC, for example, you would literally times that red, green or blue value by 8. So this would then convert that into 4 tiles across by 4 tiles down. Each frame would be 4 by 4 tiles. So if we wanted to convert this into a 256 color bitmap, we we'll just select that mode there. Now there's options here. If you leave this as 0, 0 and you drag and drop this in, then the output will be the whole image as bytes. So I've not covered, depending on when you watch this video will depend whether I've covered the 8-bit format for the Game Boy Advance or the DS. So I'm not going to be going into tremendous detail about all of that. I obviously will in the video which explains that. So if you leave the size as 0, then it will convert the whole image width. However, you can still specify frame sizes. So like I said, these are 32 by 32 here. So now what this will do is it will split this one frame here as a 32 by 32 pixel image, and this as a 32 by 32 pixel image. Now if you were to save these, okay, that's not right there. Maybe I've got the size wrong for them. Yeah, I have. Okay, they're not 32 by 32. Let's double check the size of them. There we go. They're 48 by 48 actually. There we go. Now, and if we open that in the text editor, zoom out for there. So basically, the each pixel is 1 byte, and then that 1 byte refers to a color. So in the case here, there's 32 colors here, which it says there. So the color range here is going to be 0 to 1F per pixel. Obviously this takes up a good chunk of memory there. So this then brings me on to another format in here. So I've got two compression format. Well, yeah, technically it's the same sort of format really. So I use run length encoding. So what that is, for any of you that are not familiar, is it's a compression format. So what happens is, in this case, you take one color from the image, then you count how many occurrences of that color occur before the next color is found, and then you store both of those numbers, and then you carry on until you've basically drawn the whole image. So if we do this again with run length encoding here and then save that, and then we go and have a look at that, and zoom out, you'll see that that looks a lot different now. So if I go into this a minute, so it's found color 0, and then that occurs 8 times. Next it's found color 1, that occurs 1 time. Then color 2, and that's occurred 1 time. So the reason why it's in lines like this is because it stops at the image width. So it's not compressing all of the it's not compressing the whole width there. It's just compressing the width of that one frame. And then it stops and goes to the next line. I will show a demo code of that. We'll do that now actually. Where are we? So this demo here, this shows 256 color tiles in action here. So if you go view the tiles here, you'll see that the font set is using 16 color tiles, and then the those large characters, which are 48 by 48 pixels across, are using 256 color tiles. And then if you go and have a look at the color palettes here, the first one there is for the font set, and then the next are for these characters here. I will provide the source code for you to jump in and have a look at for each of the demos I'll show today. So one thing to note there as well is this box here. So what this does is it allows you to create these characters here, but then when you go to export the colors, you can change what it takes the start to be. So in the case of that other example we just saw, they started at 16. And the reason why you would want to do that is because when you use 16 and 256 color tiles together, obviously there's only one palette that they all use, which is the block of 256. So you have to be aware where the palette ranges for the tile sets for all of your image lie. So another useful thing as well is this here, which is what I've included. So what this will do, by clicking on this, is it will ignore color 0. So the dark blue color here will not be exported with this image. What it will export instead is color 0, which would be the obviously color 0 in the global sort of 256 colors. And then what this does here is the first color it finds, it won't be number 1, it will be number 16. So if we save this again, and then reload that, you'll see color 0 is normal, but then the first color is color 16. So that's a hexadecimal for color 16. So that kind of covers using tiles here. So if you wanted to draw a background, for example, so this here is a nice background for us. Let's zero all of this out here. So here we go here, nice picture of Princess Peach. So this would convert this to a 256 color bitmap. and then we could then, in a bitmap mode, then draw this not directly into VRAM. Again, I've not done a video on bitmaps here, but on the Game Boy Advance, I'm not totally sure with the DS whether it's the same. It probably is, but you can't write bytes into video RAM. You can only write words, which are 16-bit numbers. So a way around that is to you can sort of create a kind of frame buffer, if you like, in EWRAM, and then plot your bytes there, and then copy that array into video RAM as either words or double words. So that is unsigned 16-bit numbers or unsigned 32-bit numbers. And then one thing to be aware is, so you see this fits nicely on the Game Boy Advance screen here, 240 across by 160 high. And this will export this as bytes. But when you get to the DS, its screen resolution is 256 by 192. So you cannot export 8-bit compressed bitmaps using all bytes if the width is greater than 255. Then what the code for this program does is it changes the run length output to use words instead of bytes. So that's something to be aware of. So I'll quickly show that demo here. Where are we? Okay, it's not in there. Sorry, wrong one. Got too many tabs open here. There we go, and they're all called the same sort of thing, which isn't helpful either. So I'll show you the 8-bit bitmap here demo. So here we go here. So what that sound is there is it plays a sound whenever it hits the borders here. So what this is showing here is this is actually another bitmap image here. And the reason why that sound is going so slow is because this is running so slow, because it's constantly drawing all of these. Aren't sprites or anything. This is all bitmap manipulation here. And one side effect is the sound engine is dramatically slowed down. So I might jump into the code here and show you quickly actually. So the peach image is compressed. It uses run length encoding, like I said. And then the ghost doesn't. There is a font in here, but you obviously. So don't worry about that. The core of the demo was just to show you how to use both of the run length encoding. Okay, so one thing we'll show you here is I've got a program to, or rather, you'll notice that S2D looks totally different here. So this is the S2D in bitmap mode. So there's no tile commands in here. We literally have some blitting functions here. So what blitting is is it's basically copying one block of pixels over the top of another block of pixels. So and there's also a few other interesting little commands here. So if you've ever heard of a language called QBasic, then some of these might be familiar to you. So pset is basically that sets a pixel on the screen. So here we go, we've got our virtual screen set up in EWRAM here. So this allows us to use nice commands here. So this will draw a filled rectangle. So there's one thing to note with this, if you ever play around, is there's no border checks. So be careful where you draw, otherwise you might crash the Game Boy Advance, which is fine if you're running an emulator anyway. Just be aware that the pixels need to be constrained to 240 by 160. And then there's this here will draw the compressed image onto the pixel screen here. So this is obviously using the 256 pixel bitmap mode, which is mode 4. So all you need to do to reuse this is call S2D init, and then it will change the display controller to mode 4, and then it will enable background 2, which is used for the bitmap display. As we're in 256 color mode, we can literally treat the whole color palette as just an array of 256 colors. So we can just set colors here, set the color start, the color amount. That's it for that. Draw rectangle, we'll draw rectangle anywhere. Pset will draw pixel anywhere on the screen. You will need to obviously know which colors are in your palette and where. Clear background color. So did I actually implement that? Okay, I did, yeah. So this just fills the virtual screen here with whichever color you use. So these aren't the fastest pixel manipulation code here. This is kind of just to show you what you can do, and it runs slow because I'm not handling any special ways of manipulating the background under the characters. So all of the setup code here is bare minimum. We literally load in the well, there's no real need for that, as I didn't actually implement that the font at all. So we've got the in fact the font is actually already converted into 8x8 pixel tiles. So you if we come down here a minute, so if I quickly do this a minute. Okay, so as the font tiles are in 8x8 pixels, each graphic, if you like, or image is offset by 64 pixels. So if we have tile ID there, and then we push that in. This should okay, it's because the it shows you 3 of them there. It's because the where are we? The font. If I open this up a minute, it's because the first, actually it's not that font. It's this font here. You see the first couple of rows are blank, so I would need to start at 32 there. Anyway, this shows off what you could do here. You can manipulate the pixels. The reason why this is running quite slow is because we are drawing all of these every update. But the pixel modes are quite slow to do a lot of stuff with. You can obviously use sprites with the when you're in the bitmap modes. So now I'll get to the 256, sorry, the 16-bit demo here, and I will close this one. I won't save any of that. And obviously the I'll have links to all of this below the video. So I'll now get into the so as you can see here, this looks a lot more colourful here. So this is doing the same routines as the other one, except we're using 16-bit here. Now, as we're using 16-bit images, we don't need to worry about recording the colours used for them. So obviously these are massive here, massive images being moved around. So the same routines are being used here as the 8-bit demo. There's the 16-bit run length compression and the normal blit-in functions. And there's also a trans-blit function. I didn't cover that properly. So what that does is wherever it encounters a certain colour in that image, it will not draw it. I'll quickly show that here. So here we go, this function here. So what this will do is, if it finds color 0, so I'll shoot a graphic here. So this is Yoshi here. So if it finds color 0, so another thing I need to show you as well is these are using the alpha flag here. Again, it doesn't really make any real difference on the Game Boy Advance because it doesn't see any of it, but obviously it does see it on the DS. So each pixel here is actually an unsigned 16. So if I zoom out enough, you'll notice the pixel patterns there. Zoom back in here. So all the transblit function does is when it's drawing the image, so what it first does is it takes the image data into ink, and then it checks to see whether that color is greater than 0. So if you do this command here, if, and you put a number in there, if the number is not equal to 0, then it's true, and then it executes that. So if the pixel color is not equal to 0, it will then draw it. And this is the same for the 8-bit stuff as well, 8-bit demo as well. So I'll link the source code for all of these after this video. So again, if you're working with 16-bit here, click the 16-bit flag on here, 16-bit icon. So whether it's a 16-bit image or a 16-bit RLE. So you can, obviously, instead of drawing just individual images here, you could convert that into image frames, in which case you just need to put the size in here. This box is obviously ignored in 16-bit. So another thing to note as well is this run length encoding. So initially it goes across the image. Now if you untick this, it will go down the image instead. So another useful thing for the 256 bitmap mode here is when I create levels for games. If I come up here a minute, I think there's a level here, so if I open this a minute, I don't think it's actually in that demo though. So you can create levels using the whichever graphics program you use, and you can use the same approach. Have a color palette up here, and then each pixel then represents one tile type. And this is a nice, quick and easy way to actually convert levels, create levels into tiles. And then you can just drag and drop that in, convert it into a 256 pixel bitmap, and then each byte is then representing a tile. So that image then becomes a virtual tile map. So I use this process for all of the games I make at the moment, and also for the other consoles that I use as well. This conversion process here is very useful. That's pretty much the Game Boy Advance one here. So let's jump into the DS here. Oh, sorry, that's pictures. So the conversion process for the pictures is obviously exactly the same as what I've showed you here. So what we do need now is to so this is the DS demo. So this is working off of the Hello DS like tech specs video here. So we've got our graphics here in the bottom. There's our Yoshi as seen on the previous for the Game Boy Advance, and there's our Toad there, and then we've got a Pokemon image in the bottom there. So I will quickly show this demo off here and explain some of it. It uses basically exactly the same functions, just this at the bottom here is a 16-bit. As you can see, there's a lot more colour on these here. So we've got, if I exit this and then we jump into the code. So there's a lot of code in here. There's a lot of stuff which I'm obviously not going to jump into. all I want to sort of point out in this one is the pixmap side of things. So in this demo here, the top screen has an 8-bit bitmap configured for one of the layers, and the sub screen, which is the bottom screen, has a 16-bit one configured here. So on the DS, obviously, we can have a number of different layers active at the same time on each of the top and bottom screens, which means we can have tiles and we can have bitmaps on the same screen, as we have the memory to do all that. So the ones I wanted to sort of just point out here are these same sort of commands here for the sub screen, where I show how to draw a compressed 16-bit image and then draw a non-compressed 16-bit image. So basically these here are for drawing like a backdrop. And then we have our transparent blip routine here, same as before, and our pixel set one here as well. So I did actually put in boundary keeping here. So what this means we could do here, we jump in. So it's still got loads of the 3D stuff in here. I literally just wanted to cobble together a quick demo. And then this is just the code here. We draw a backdrop, and then we just draw the Yoshi bitmap and the Toad bitmap here. So one thing to note with working with bitmaps on the DS, it is fast enough to actually create a game using this. So you could, as I did when I first sort of started off with the DS, is I ignored sprites totally, and I ignored the tiled modes, and I created a game where I just drew everything directly using pixmap manipulation. So a pixmap is basically just a bitmap. It's the same thing, basically, different terminology, where you everything is just literally a load of pixels. For example, these here, if you show a pixel grid here, you can think of this as just a map of pixels here to draw this, or a pixmap. And then we literally just move them around here. These blitting functions here are not very efficient. Again, they're literally just here to quickly show things off. I obviously wanted to give you a demonstration of using the graphics converter here. So I think I've covered everything here, all these modes here. So one thing left to show you is what happens error-wise. So we're back in, say we're in 16 color tile mode, and if you're working with just 8x8 tiles, switch to palette mode here. So here we go, here's our first image here. So we've only put 2 colors in the palette, but we have 2 illegal colors in there. So if we go to save this now, so the first illegal color it's found is at pixel 2.2, which is right there. So it's given you this location here. So what that means is that you can open back up Libra Sprite here, So if we move that across here, so it's saying at pixel 22. So if we zoom in here, so notice down here when I move a mouse around inside the image, it shows you which pixel we're currently over. So we can look in here and it's illegal pixel. Now one thing to note is it says F8, and the reason why it's saying F8 is because as soon as this image is dragged and dropped on here, everything is converted to 16-bit. So it says F8, but what it actually is FF. The reason for that is because if you divide 255 by 8, as I will show you here, so there we go, divide it by 8, we get 31, times that back by 8, and you get 248. So this is bright red here, it's that colour there. Press I, change the pipette, and then that shows you the colour there. So if I then put that in there and save that again, so we go back here, we fix that now, drag and drop that back in. It's found 3 colours now. If we go to save that, oh no, it's found another illegal colour, so this time it's all zeros, so that means it's black. So that's the alpha flag there. As you can see, it's at 5.2. So if we go to 5.2, there we go. So bear in mind these colours here are just in 24-bit format. There's no alpha, it's showing there. So then what we would need to do is to put that one there. Then if we save that, and if we drag and drop that one over again, now it's found 4 colours now. Now we can save that properly. I'll put some info in here to say how to what these icons do if you forget. And that's it for this video. I will leave links to the graphics programs which I recommend to help you manipulate graphics, and I will leave a link to an exe file for Windows users, as it's obviously easy to build for Windows, and for the Linux users I'll leave the source code for Linux for you to build yourself. All you need is SDL2 and then it should build fine. The other library which it uses is called Tiny Dialogue. Now what that does is it allows us to easily use whatever operating system's native dialogues, for example the load image or save image, even like error messages, like pop-up boxes, that sort of thing. The program itself is kept minimal because I don't want to invest in a huge bloated library for using GUI. For example, here we have, this is examples here, like a button or a text box or whatever. All of these here are obviously using some sort of a graphical user interface library, which would obviously take ages to learn, and then when they update it, everything you've learned is kind of broken slightly, and then you have to learn it again, and I don't want any of that. So I kind of wrote sort of my own, to some degree, using immediate mode, as in you just draw these things as and when you need them, and you keep the data for them around yourself. So that's it for this video. Let me know if you've got any questions about the DS2TILE graphics converter in the comments below, and I will catch you next time.